Well, what can I say? Dzień dobry. It's really great to be here in Krakow. Really looking forward to this in this city of the dragon. And I guess you have the story here about what is called Smok Wawelski, the dragon, and that inspired a lot of other people to write stories about dragons. I hope my story about data-oriented programming will also give you some inspiration to give it a look. Just out of curiosity, how many of you have heard about the term data-oriented programming? Okay, that's like quite a few people, more than I had anticipated. Very good, very good. So, we're going to have a good look at this. It's not a Java thing, it's not a new thing. It has been around for some time. Actually, I'm not on the screen yet here. Now I am. Good. This is shortly about me, Ron Veen. I'm a Java developer for way too many years. Special agent and team rockstars, and that means that we actually get to do these kind of presentations. And currently I'm writing a book with my colleague David on Jakarta EE migrations. Looking at agenda for today, we're going to talk first, there's a little introduction, the evolution of a traditional Java application. Then we're going to have a look at, okay, what are the principles of data-oriented programming? Then we're going to look how Java is supporting this way of programming. And finally, we're going to look at some examples. So, evolution of a basic application. Right, meet Marcin. Marcin is a developer, and he's a happy developer. He's working at a company, and Marcin, he loves timesheets. And there's a good reason, because he's the one at his company who's responsible for the timesheet software. And I guess this is something we all have to deal with in our daily lives, monthly, weekly, and if you're really unlucky, on a daily basis. But the timesheet application, it was quite simple at the beginning, wasn't it? I mean, you had a timesheet header where there was a user, you had some timesheet details related to projects and activities you did, and it was all quite simple. But that one day, the project manager stormed in and said, Marcin, something is really wrong, because suddenly there's this guy, and he's not even on my team, but he added his timesheet to my project. So what is wrong here? And Marcin had to look at the code and said, yeah, I know, we have no limitations on that. So we need to change that. And thus he did. And suddenly there was a connection between users and projects, so you could only assign and book hours on specific projects. So everything seemed to be fine again. The world was okay again. And then, not much later, the angry project manager came in again. I guess you can see who's the bad guy in our story. So the project manager came in and he says, listen, what happened now? We're doing a project on migrating, and someone is booking or writing hours on a code that is not meant for that. So Marcin had to look at the code again, and he said, yeah, that's right. Basically, there's a connection. So he changed the system again, and the system became bigger and bigger. And not only the system, also the company, it grew. There were more users and more roles. So the next thing that happened is that suddenly there wasn't just the users anymore. No, we had to have special roles. So we need to have like approvers that actually approve your timesheet. And we need to have project managers. They need to have their own role in the system. So the system became even bigger. And then they bought companies. And before you know it, they got to multi-tenancy. More organizations in there and more data. And then we need to have more reports and more timesheets. So the system grew and grew. And this is basically how we have developed our Java projects for a very long time. We have class hierarchies. And very many of our rules are really into this object and class dependencies that we set up. Then, at one point, the owner of the applications came in and said, well, you know, we did really great, and we have opened our application for external users, and now we're going to bring it to the web. So we need to see how we can modularize our application, scale it independently. Oh, you can feel where this is going. It could be modules, it could be something like microservices, but Marcin had to look, okay, what domains can I identify? So he came up, okay, probably this is a good user domain. And there's something related to timesheets. And there's something related to projects. And these things here, they're more like security and who's allowed to do what. So we're trying to identify these different domains to have them scale independently and horizontally in the system. And our traditional code, if we go back to the previous thing and we have users, then we have the traditional code. If you look at the user, this is the way we did things, isn't it? We have both state and behavior in one class. So here we have like the username, the email address, whether the account is active, and how many login attempts have been made. And then we have code that is actually reacting on those things. So if a user fails to sign on, the register failed login is activated. It increases the number of counts that were failed, and then it checks against a threshold value to see if the account should be blocked. But basically, we see a tight connection here between state and behavior. And this is our traditional way we did Java, and of course it makes all sense. But moving on to data-oriented programming, if we use smaller modules, do we still need these object structures and these class structures that depend upon the state that is in there? Or can we just say, let's separate the two and treat them differently? And there were a lot of articles about data-oriented programming popping up recently, and Marcin read them all. This one is from Brian Gatz, the language architect, and he says, well, Java has really great new features, which allows us to do data-oriented programming. And there have been some podcasts on there, and Gavin Bierman talked on Java 1 about this data-oriented programming. So apparently it's a thing, and Marcin is very keen to look into those things. So let us have a dive to see what data-oriented programming actually is. Well, it's based on 4 principles. We'll look at them first and then go into a bit of detail. First thing you should remember, it's a general concept. So probably when I read about a few of these, I thought, I'm never going to do that in Java. But they're general concepts. So just look at the concepts without trying to translate it to Java directly. So first thing is you should separate data from logic. Then the data should be stored in generic data structures. Again, we'll dive into the details just after this. The data should be immutable, and the data schema is separated from the data representation. Looking at the first principle, separate data and logic. Well, one of the advantages is that code could be reused in a different context. To give you an idea, so we just have data. So what we saw before with the user, the password, and all those fields, they would be in a separate class. And then on the left, there is another class which contains code that operates on that data structure. Well, that code could be reused in different contexts. To give an example, what we saw before with the login method, where if you have too many login attempts, the account gets locked. Well, traditionally how we would do it in Java, say we want to reuse it, it was in the user thing, but now we also want it at the manager side and the approver side. So we could duplicate the code, but hopefully in Java we would choose the sensible solution, probably introduce an abstract class where this functionality would be lifted into, and then the other 3 classes could inherit it from it. But what if we would separate the two? What if we just say, okay, here's a piece of code that checks the login attempts and actually just gets a user object passed, and then he can handle it in such a way. There would be a different way of working that we were used to, but we don't always need these object structures when we got really smaller applications. So you could test it in isolation, meaning if I want to test this login function, I could just pass it, create a user object, pass it, and it will do its thing. I don't need to look, did I initialize all the instance variables in this mixed class together? It tends to lead to less complicated systems, and the reason for that is that your object structure or your class structure is first of all split in 2, and then the hierarchy structure tends to be smaller. Next thing is that data should be stored in generic data structures. What are generic data structures? Well, in this case, I guess they would be lists, maps, vectors, queues, those kind of things. Doesn't really make sense directly for us Java developers, but again, think outside of the Java box for a second. So the user class we just saw would then be represented as a map, where the field name would be the key, and the field value would then be the value of that map. So it would allow for a flexible data model. Makes sense, right? Because if they're in a map, it's easier to add another field saying, is he an administrator? You could just add a field with a Boolean value, and that would work. And you could use generic functions that are not scoped to our classes. In Java, we have the luxury of very many libraries with utility functions. Some other libraries are not that lucky, or languages are not that lucky. So for them, this would apply. I would say for us, not so much. Then the data should be immutable. And immutability has a lot of benefits. But what do we mean with immutability? I was born on the 26th of February, and if that is in an object, you could change that value, but it doesn't change the truth. I will always be born on the 26th. So you might change a reference to the data, but the underlying data never changes. So that means that if you want to change values, you return a new object. Then immutability gives you predictable behavior, because if your code is changing somewhere between A and Z and it could change everywhere, that's really difficult. But if you ensure that it is only changed at a few places, that is much more easy to reason about then. And finally, as we all know, it enables safe concurrency. If your data is immutable, no problem if multiple threads are accessing your data at the same time. The final one, separate data schema from data representation, has all to do with the fact that your data is kind of typeless, and the constraints on it are externalized. So that could, for instance, be with an XML schema definition, right? There we say, oh well, this field that's a string, and it's either mandatory or it is not mandatory. And you can do the same with JSON schema. So those are options. Whether they're valid for Java, we'll get to that in a second. So, how does Java support modern data-oriented programming? We are going to look at 4 things. We're going to look at records. We're going to look at sealed classes. We're going to look at pattern matching. And we're going to look at switch functions for pattern matching. Some of these are new, some aren't new. Let's just see. Records, who's familiar with them? Okay, that's quite a lot of people. Great. We'll start with records. And this is how you define a record. And a record is just a data carrier in Java. I think it was added in, not really sure, Java 14, Java 15. And this is basically all you need to do. You say it's a public, instead of a class, you say it's a public record, it has a name, and then you define the instance variables that are in this record. And when I say instance variables, I should say they're actually final instance variables. So once the compiler, the constructor completes, then they have their final value and can never be changed again. By doing this, the compiler does a whole lot of stuff under the hoods for you. It generates, well, of course, in all R constructors, otherwise you couldn't initialize the thing. It will generate your equals, your hash code, your toString, all the standard things that your IDE would generate. It just does it under the hoods for you, so you will never see it, though you can override it. Creating a record is as simple as calling it like this. Of course, we use the var keyword, and then we say, okay, it's a new user record, and then you assign the 4 values. Retrieving a value, because like I said, it's a final thing, it's immutable, so we won't have setters. We do have getters, just not in the Java Bean convention type, so instead of you using get email, you would just simply use the field name and retrieve the values for it. And finally, it has a few other fancy features, such as the compact constructor, because maybe you just want to validate the data that is coming into your record. What you can do is write a compact constructor that you can see. You just specify the name. You don't have to specify the arguments, because the compiler already knows. He knows it has 4 parameters, so no need to talk about it here and mention them. And then you can do your validations. The validations I'm doing here on email, password, and login attempts, they're all on the parameters. They're not on the instance variables. And as you also notice, once the validations are done, I'm not assigning them, these parameter values, to the instance variables, because there's no need, because the compiler will do this for you. So Java records are very concise data containers that you just can pass around in your system. Great. Next, we move on to sealed classes. And sealed classes, they're all about inheritance in Java. And if you look at your inheritance options in Java, if you want to specify who can inherit from my class, well, basically, you kind of have 2 options, right? You can say, I'll just make it final. No one is going to inherit from my class or extend it, like the string class. Or you basically could leave it out, and then technically, anyone who has accessed it via the access modifiers can override the methods in your class and can extend from it. Sometimes you want to have a bit more of fine-grained control over object inheritance, because it allows the compiler to reason about certain things, take care of certain things for you, which we see a bit later. So, how do we do that with sealed classes? And everywhere where I say sealed classes, the same applies to interfaces. A sealed interface in this situation, here we say sealed interface user, and then he uses a new keyword, permits. And he permits the approver, the project manager, and the regular user. What this is saying is, okay, great, yeah, I can be inherited from, but only by these 3 classes. If any other class tries to inherit from user, the compiler will actually give you an error message. Now, all these classes that we mentioned there, the approver, the regular user, and the project manager, they have to define themselves again how they are handling the sealedness of their class. And then there's 3 possible options. The most simple one is with the approver, because the approver says, I'm a sealed class too. And then he needs to specify in its permits clause who is allowed to inherit from him. The next option would be that you make something final. Here we're making the project manager final. We definitely have enough project managers in this world, so we'll just keep it final. No one has to inherit from it. And the third option is that we specify the first hyphenated keyword ever in Java, a public non-sealed class. And basically what you're saying here is, you know what, I don't care who inherits from me. Anyone can. So this is basically, again, almost like you would specify, like we would do normally when we don't specify a final. And though it might seem that this doesn't make sense because you have this very fine-grained control over who is allowed to do what, and then suddenly someone comes, no, I don't care, anyone can inherit, but we can still reason about this based on the fact that we can reason about a regular user, and that still catches all its subclasses. Java 17 had the first version of pattern matching, and pattern matching is a concept that was quite new, and it has a predicate, just basically a test. It has an object where you run this test against, and if the test returns true, so is successful, then some number of pattern variables are being created, which are in flow scope. That's a lot of text, but let's look at an example. So we say here that we have this static method allow approving user, and then we say here return user instance of approver. Well, here the predicate is instance of approver. This is not the instance of method that we all knew. This is the pattern matching instance of, and the object to test again is to test against is the user, and the pattern variables is A. So basically, if this test is successful, then A is actually an approver object. The user object is casted by the compiler to an approver object. And then you can just address A and call any methods on it. And again, the flow scope basically means that A only exists between the brackets. Later we got pattern matching for switch. So here we have almost the same example where we say, okay, we're getting a user in and then we're switching over this user, and then we're asking, okay, is it an approver? Then we assign A to the casted value of user as an approver and return true. This is the new switch syntax with the arrow. Same with project manager, same with regular user. Now there's something that the compiler found out here for us, because the compiler said, normally, if you would have a Boolean, you could say true and false, and the compiler would say, well, that's all possible values for a Boolean, fine. But if you would do an integer, the compiler would say, wait, friend, you can't just say 1 and 2, then you have to have a default clause. Normally, it would do the same for objects, because it could be any kind of object. Still, the compiler can reason about that your match here is complete, because you told him that a user can only be an approver, a project manager, or a regular user. The other thing we should notice about here, if this was a switch with an integer, we would say, okay, switch integer, and then we would check for the values of the integer. Can you now see that here we pass in a user and we're switching? We're not checking, oh, is this of this class, but we're really treating the data here as a first class citizen. We're treating approver here like we would approve.
What if it was null, by the way?
That's a good question, brilliant question. I think it appears on the next sheet, but it will be there in a second. Very good. The question was, what if user was null? Would that give a null pointer exception? Because indeed, in the old situation of switch, it did. We're going to do one more. It'll be on the next slide, I promise. So here we have an additional feature. because when pattern matching was introduced, we had the instance of and a switch, and we also had the guarded pattern, which you see on the first case line in the bottom example. So we say, yeah, approver, that's great, but we only want to return true when it's an approver that is actually also active. So that is why we suddenly say case approver A when A is active. Can anyone guess why I'm still putting in the other approver thing? Because approver was already mentioned once, so why would I have to put it in again? Right, won't keep you any longer in suspense. Switch has to be exhaustive, like we said, right? You need to deal with every case, especially because, as you might have noticed, this is a switch expression, so it returns a value. So it needs to know from every situation which value to return. Now, if I would only say case A approver where A is active, I would never deal with the situations where A is active would return false. Compiler recognizes that, smart as it is, and you need to put that other statement in there as well. It's on the sheet, promised. The same happened with pattern matching for records. We had records, right? So they were added to the language, and then so we could also start using pattern matching on records like this, but it gets even better. We could use the same pattern matching here and use it together with record deconstruction. So let me explain that. First of all, as you can see, case null is now a valid value if you do cases. So if record would be null, it can handle it. Before you were right, you always had to check before you went into a switch, is this value I'm testing against, is it not null? Otherwise it will give you a null pointer exception. That was tedious, so the compiler boys from Oracle decided, no, we'll do a case null and so we can handle it in there. But more interesting here is the situation case user record, and then I'm saying E, P, B, and A. Basically, what we are saying here is, if the record you have given me is a user record, could you then please extract the instance variables which are in there and put them in the variables E, P, B, and A. So it kind of deconstructs your record into variables that you can access dynamically and directly. I think we're now at JDK 20, right? So in JDK 19, you could actually have then used a user record and then access that, but they took that out again because it gave problems, and now you have to extract them into the individual parameters. And it got even a tad better if we switch between the two. Here's the code, because here you say case user record and you still had to say what type of instance variables are they then, and what variables do I want to put them in. In Java 20, which is out now, you actually don't even have to do that anymore. You can let the compiler determine what type of variables are in there. So you don't have to specify anymore, yeah, this was a string and a boolean. You have to have the right sequence, but for the rest the compiler can work it out for you, and you can still work on this like you would want to. Then in Java 20 they went even a bit further, and they made record patterns usable with the enhanced for loop. We have the regular enhanced for loop for blah blah blah. In this case, a list of user records, and then list through each and every user. Normally you would say something like list user record U and then semicolon users, but now here you can already deconstruct the user record into the variables and use those variables directly into your code. Great. So, how can we combine Java and data-oriented programming? Again, here are the 4 principles, and let's look in how much of them can be applied to Java. Well, the first one, separate data from logic. Is that really so strange? I mean, I guess, who has worked with Spring here before? That's the majority of people. And I guess the ones that didn't put up their hand, they're the ones who worked with enterprise Java beans, right? And didn't we there, especially with stateless session beans, didn't we there already separate data and logic? Because we would have our service methods, well, that we would annotate as service or annotate as stateless session beans. And those would really, well, the name says it, right? Stateless session beans. There would be no instance variables in there. So it is not that strange to use it. You could use it that way, or you can use them as static methods. Now, I know static methods hurts because we're Java developers, so we're thinking classes and in instances of classes, and we're not going to use static methods because, you know, but actually, there's not so much against that. Especially if your code modules, if you're splitting your code into smaller modules, it would make much more sense. So I think principle A is something we can really use. Data is stored in generic data structures. Well, great. Since Java 9, we have this great of method, so we can list of, map of. So yes, technically we could do it like this. Get a user record and then say, oh, I'll destruct it into something like this. But I guess we can all agree this is not something we ever want to do, because we really love the compile time type safety that the Java compiler gives us. So I don't think this is something we would like to do. But maybe we can think of a different way, of a generic form of a data object. I think we just came across one that might suit us very well. Also, if you would use the above example, then, you know, getting values from fields is really bad because you need to do all lines of casting, and it's really, really, really ugly code. Data is immutable. I think we just came across records and said, oh, they're immutable. So maybe that would be a really good fit for us. So, and then finally, well, data schema separated from representation. We just said we're not going to do this strange. We're going to rely on a Java compiler for type safety. So we're not going to use that one either. So basically, separate your data from logic and be sure that your data is immutable. That might get us to data-oriented programming in Java. Now, how could that look? Now we get to the code, and it's kind of complicated. It's not complicated, it's just a lot of new keywords used all together just to make it really confusing. Here we have a sealed interface, opts. And as you can see, it's generic type, so it could be of any type. So basically, this is an alternative for the optional method that we already had since Java 8, right? Optional. Your thing can have a value or it can't, and you don't know for sure, so you pack it in a container and you can ask the container, is there something in there or isn't there? It's a bit of Schrödinger's cat situation. So, and this interface here tells us we have 2 possible outcomes, only ever 2. Either it has a value or it doesn't have a value. And then if the way you would use that would be in a situation like this. Say we have some code. We generate a public static void main, and we say we'll call the run method. It should have had the arguments in there by the run method, by the way, because the run method gets the command line arguments. And then there's 2 methods. There's a validate, which returns this optional, in our case, string, and there's a process method. If we look at the implementation of these methods, it will look something like this. The run method says validate and then process the value. So the validate says this. If there's no command line argument, then it should return a new option of type none. And if there is something, then it should stuff the first command line argument into the sum value that we are returning. And then the process, and this is where the beauty slowly comes in, the process, it knows there's only ever 2 possible outcomes. Either there is a value in there, and then we'll process it, or there isn't. Does this make any sense? Or have I lost everybody already? Okay, gonna lose you a bit more then. Because say we have this real world example, and here we have a REST resource. And it basically has two methods. It has a get method where it is searching for a certain value, and it has a post method where it creates some data. There's a few other methods there as well, which will come later into play. But let's have a look at the search method first. The search method returns a search result. Again, it's a generically typed interface, and it can be a search result of any type. And there's three possible outcomes. It can return a record, no result, easy. It can return an exact result, or it can say, oh, well, there's multiple hits, so I'll give you multiple results. It's basically kind of an extension of what we saw before. Then we can do the find projects method, and for simplicity, we'll just say it returns an exact result. Doesn't really matter for us, it just returns that one. And then the search method can again be implemented like this. It calls the find projects, and again, the outcome can only be one of three possible states. And every time when you use sealed classes, it can only be like that. You can never have invalid situations. And that is the beauty of it, because suddenly your data is this first-class citizen, and we really care about the data, and it's about the data that we're really not checking individual values in there, but really about the data. So now you can say, right, if it's a no result, then I'll show a page where it says that there's no result. Or if it's an exact result, because we search on a primary key, we can show the details right away, or otherwise show a list. And your code gets so easy to reason about, and it's really the data that is now driving the flow of your application. As a final example, we said we also had the post method, the create there with the master data. If you would look at the master data, basically for a post method, you want to validate the data that is coming into your system, and if it's any good, then you would like to store it. Well, the master data is a class that permits project, activity, and sub-activity, and they are easily implemented like this. Nothing very special, they're just three types of records. The important thing is they all implement master data, and before we had the records defined inside the interface, now we have to find them outside, because maybe you want to have some validations in here, and then it would make more sense to have them on their own. Anyways, the code looks like this. You create, you validate it, and then you store the data. And then again, validation can be completely easy. Imagine a REST resource, it gets some JSON in there. If it is null, the data was coming in and it couldn't be converted because the JSON was invalid, it would be null, and you would say, okay, great, the validation failed. And otherwise, if it's a project, you can do specific project validations, activity validations, or sub-activity validations, and it all makes sense because it all kind of fits together. And again, the data is driving your applications. And of course, the store method basically has the same thing. The compiler again knows it can only be one of three types, and you can ask the compiler and you can call code related to that. So data is really a first-class citizen in data-oriented programming, and it really drives the flow of your application. So to summarize, it treats data as a first-class citizen, it drives your application, and Java supports data-oriented programming via records, sealed classes, and pattern matching. And then I guess it's time for the cat. Only question, I guess this is the moment where I start switching to the other screen, huh? Right. Schema separated from, oh, I'll better read it here. Schema separated from representation, but what about persistent? Still, data schema reflect way data is stored at HDD. Like I already said, we're this separating from schema, from schema and representation. That's not something we would do in Java. In Java, we'd still use the strong types that we have, so that isn't really an option here. Other languages like JavaScript would actually use this way, and then depends on the persistent solution you choose, so I can't really answer for them. If code is reused in different contexts, how does my code adhere to the single responsibility? That's a good question. That's a very good question. And the answer is even better, because it is up to you as a developer, because it doesn't really matter. I can give it a different value, but it doesn't really mean. If I say validate user and I pass it an approver, that's not very different, I think it is, from validating a manager. And if it is different, then maybe you could use some strategy pattern behind that to realize something like that. So again, we're already using this in entity beans, if you're on the Jakarta EE, or you're using it in Spring Beans, where you annotating with add services. You would do the same already, so it doesn't have to be a problem. Any more questions? Okay. Oh, did you ever use sealed classes in a commercial project? I really scanned the code for the Java compiler, for the JVM, so not the compiler, actually the normal Java code for the Java libraries, and I could find sealed classes in the whole JVM libraries being used at one place, and that is actually virtual threads, where it makes a difference between a platform thread or a virtual thread. So in the threading department. For the rest, at least in Java 18, I hadn't seen any places. Have I used it? Yes, I can think of one situation where I used it. It was a system where there was a lot of classes, but we also allowed plugins. And I want to reason about the plugin behavior. So there was an interface, and so there was a sealed interface, and one of the classes that was allowed to implement the interface was plugin, and plugin itself was then non-sealed, because I would allow my users to make other plugins, but I still could reason about the plugin based on its type. So yes, I have used it. Looks like it don't need Scala anymore. Yeah, I guess Scala people tend to disagree, because yes, Scala of course has a lot of these features, and Java is always lagging a bit behind. Kotlin has a lot of these features. Again, you could do everything I explained here. You could do it in Scala, you could do it in Kotlin, or you can do it now in Java. So we're a bit behind maybe, but it's definitely true. My company won't move to Java 20 soon. Can we map the data-oriented program schema to Java 11? Maybe you could convince your company to move in October to Java 21. Not only would you jump 10 versions, but you will also get the latest LTS, so the long-term support version, with all the features in there. I guess we lose a lot of everything I just mentioned: records, sealed classes, pattern matching, switch expressions. They all came after Java 11. I'm sorry, so no, I'm afraid that is not going to work. Guess you have to change company then or something, or customer health. Having said that, I'm currently working at a project, and they're promising, oh no, we're going to do Java 17 at least. And I thought, oh, okay, that's the current LTS. And then I saw that a lot of projects were still on 8, and we needed to convert them, which there's never time for. So it happens. Switch is bad if new types appear often in a feature. Have to fix all the switch. How do you deal with that? True. You're true. Suddenly, if we would get a fourth type of user, let's say managing director or CTO, even worse, then yeah, you had to deal with that in your code if the behavior is different. That is true. But if you would introduce these new types, there would be a reason for that. So probably it is what you want. You didn't invent general manager because you thought that would be really fancy to have a general manager object in my class. No, probably there's some behavior behind it, so you want to implement that behavior. So correct, you have to fix it, but there's a good reason for it. And even better, if you don't fix it, your code won't compile, and the compiler will tell you exactly where you messed up. So fixing it is not even that much of a problem. And I guess now we're really out of questions, but still a lot of very good questions. So, having heard this great story, who's gonna now say, I'm gonna switch to data-oriented programming? Oh, thank God, I convinced a few hands. Thank you very much. So, great. Well, thank you very much for your time, for your interest, and if there's any more questions, just pop by. Thank you.